In topic 5 of chapter 2, we're going to take a look at parallel and perpendicular lines. Here are the objectives if you want to pause to look them over. Now, to help us identify background and to tie into what I've often called a review sheet, formula number 7 or hint number 7, if the slope of one equation equals the slope of another equation, but their y-intercepts do not equal each other, and the lines are parallel. And we'll see that illustrated below. And I'm calling hint number 8. If you multiply the slopes together, that is, the product of the slopes is equal to a -1, such as the slope of one being 1/3 and the other being a -3/1. That is the opposite sign reciprocal of something. The product is -1, then the lines are perpendicular. This is an upside down capital T indicating right angles here at the bottom. So this would be background. Once again, if the slopes are the same, but the y-intercepts are different, the lines are parallel. The product of the slopes is a -1. The lines are perpendicular. All right, now let's take a look at what we have here. Now the red line and the blue line, as you see, are parallel, and they're on the same basic graph, but here this y-intercept is up there, and here the y-intercept is there, but the slopes are the same. As we go on to example 1, we see for letter A, they'd like us to write an equation that would be parallel to this line. Well, this one, keeping in mind, is in slope-intercept form, so rather easy to write. Y equals a -2/3 x, but rather than the y-intercept of +4, we could say +5. So this equation would be parallel to this line. Now for letter B, we see this is in standard form. So ideally, you're going to put it in slope-intercept form. And let's just do that together. -2y equals a -10x plus 14. And again, you want to have a positive y, so divide everything by -2. And we then get y equals, this would be 5x, and this would be a -7. So a line parallel to this would be y equals 5x plus 8 or -8. Just so long as the y-intercept is different, while the slopes are the same, the lines would be parallel. Now in example 2, they want us to find a line that is parallel to this equation, it's in standard form, but goes through this particular point. So what would you do for that? Well, let's go to the whiteboard. And first, we want to find out what is the slope of this equation in standard form. So 5y, transpose the 3x to the other side becomes a -3x. Divide both sides by 5. We then get y equals a -3/5 x. plus 23/5. So we know in order for this new line to be parallel, it has to have the same slope. And we want it to go through this point. So again, let's review slope-intercept form. And I would suggest to do it this way. You're going to take your new slope and put it there, a -3/5. Your x value is going to be a -2, replacing this x, and the y is 1. And what you don't know is what will your new b value become. So I suggest get rid of the fractions by multiplying each term by that denominator 5. That's the lowest common denominator. So this now becomes 5 times 1. Here the 5's cancel out, and we get a positive 6. And then it's 5 times b is 5b. So again, using slope-intercept form, we've replaced the x and the y. We have what our slope should be. Gotten rid of the fractions, and there I have this. So now my 6, I'm going to transpose, becomes a -6. So this is a -1 now, equals 5b. I'm going to divide both sides by 5. And my new b value now is a -1/5. So what will the equation be? Well, y equals a -3/5 x, and we now have our new b value, a -1/5. Okay, let's check it out and see how we did. And we found the slope. Now, the text is using the point slope form, which is perfectly good to do. Again, there are different ways to do it, but there we see our answer, and I like the way that I did it. All right, in example 3, now this gets to be a little bit of a challenge. They want us to look at this figure and determine if in fact this is a parallelogram. Now, what is a parallelogram? Well, by definition, this side and this side, the lines would be parallel. And then this side and this side, the lines would be parallel. Now, how would you determine that? Well, you'd have to find what is the slope of each of these lines based on the graph that it's on. Now we could use the points, and that's what they're doing, but there is another method. For instance, what is the slope of this line? Well, remember it's y units over x units, that is rise over run. So let's go from here. This would be our run, which is 1, 2, 3, 4, 5. And it's a rise of 1. So the slope of this line, and it happens to be a negative since it's starting high and going down, is a -1/5. All right, let's take a look at this slope. Well, 1, 2, 3, 4, 5, up 1. This line here is also a -1/5. All right, let's look at these. Well, this is positive slope. It looks like it's going over 1 and up 2. So the slope of this line, I'll put it over here, is 2. 2 over 1. How about this one? Over 1, up 2. Yes. This is also 2. So the slopes of these two and the slopes of these two are the same. So this is, in fact, a parallelogram. Now, to show you what the book is doing here, let's just go down. And they're proving by using the slope formula on those points that the sides are with the same slope, therefore parallel, and proves that it is a parallelogram. Now, for background, once again, slopes of perpendicular lines. We said the product of the slopes would equal a -1. And what makes a line perpendicular? Well, it's that the angle that is formed is a right angle between the lines. And that would be background, and they're laying it out very nicely here. And you can pause and read this over. In example 4 now, example A, what would be an equation that would be perpendicular to this? Well, it's going to be one whose slope is the opposite sign reciprocal of this. So that would be a positive 9/4 x, and we can get it to go through that same point here, plus 2. So this was the easy one when it's in slope-intercept form. Now, the next one's going to be more challenging because we need to find the slope of this and make one that is perpendicular to it. And we'll go to a whiteboard to do that, and I can get rid of this one here. So, finding the slope, this will be a little review. So m equals 1 minus 3. 4 minus a -1 makes this a +1. So this is going to be -2 over 5. So this would be the slope of a parallel line. So the slope of a line that's perpendicular to that would be the opposite sign reciprocal, that is 5/2. And we want it to go through one of these points. So let's use y equals mx plus b. Now you could also use the point slope form, but this one I think is more direct. Our y value is going to be a 1. Our new slope is 5/2. Our x value is going to be a 4. And we have to find out what our new b value would become. To get rid of fractions, I'm going to multiply each term by the lowest common denominator, which is a 2. So this becomes 2. Here the 2's cancel out, and I'm left with a 20, and then plus 2b. I'm going to subtract 20 from both sides, and I get 18. A -18 equals 2b. Divide both sides by 2. I get my new b is a -9. So my new equation then that would be perpendicular to the line that has these points is going to be y equals my new perpendicular slope 5/2 x minus 9. And let's see how we did here. Well, the book is choosing another y-intercept, which there, of course, could be many. And notice that our slope is 5/2, and they didn't use one of the points that I used. Okay, let's go on. As we look at example 5, we see an equation y equals a -7, but they want a line that's perpendicular to this that goes through this point. So let's go to the whiteboard and we'll do a little sketch. We haven't done much sketching here. So there's our equation and there's our graph, and it's going to be a horizontal line going through 3, 4, 5, 6, 7. And I'll even change colors for this. And that should be at 7 here. So the equation of this line is y equals -7. Now, where is -3, 13? Well, -3 is going to be here, and 13 is way up there. So what would that equation be that's perpendicular? And we know it's going to be a vertical line, which is sort of like that. And then what would the equation of this line be? Well, going into our toolkit, it's going to be x equals -3. And we can actually pull it right from this ordered pair. All right, let's check it out. And there we see it right there. Now, given some background information for figuring out whether lines are parallel or perpendicular, going back to what we said in the beginning, if the slopes are the same, y-intercepts are different, the lines are parallel. If the product of the slopes is a -1, then the lines are perpendicular. So looking at example 6 now, and if you're taking notes, you should always be writing the example number down. How do we work these? Well, in example A here, both of these are in standard form. And let's go back to red. We'd have to put them in slope-intercept form. Y equals mx plus b, so we can easily compare the slopes. So let's do that. So in doing this first one, and I've copied it correctly, and I don't need to worry about the y-intercepts here. I'm just going to compare our slopes. And I started to solve these. Here I'm going to divide both sides by a -7. So our slope here is 3/7. Now, in this next part, our slope is, after dividing both sides by 6, a -7/3. So notice that 7 or 3/7 and a -7/3, This is the opposite sign reciprocal of this. So if we multiply them together, our product of the slopes is a -1. So we end up with these lines being perpendicular. And let's check that out here as we go back and looking at this. Here, this is 3/7 and this one is a -7/3. Now they're actually writing the y-intercepts, which we said we didn't need. So the slopes are not equal. The slope, one is the negative reciprocal of the other, so the lines are perpendicular. All right, let's go on to part B. Okay, looking at example B, it's sort of wild here. So we have this. Now to put this in slope-intercept form, we have to take this part, move it to the other side where this is the y-intercept. Okay, so this would just be a plus 263/4, and that's what y equals. So if we got rid of this parenthesis here, our slope here is just 9x. So keep that in mind. Our slope is 9x here. Now I took the ordered pairs they gave us, put it in the slope formula, and figured out that this slope was 9. So again, you don't have to worry about all of this stuff here. So here the slopes are the same, and I'm assuming the y-intercepts would be different. So these lines would be parallel. And they gave us a very easy one there for the last. Here our slope is 3/4. Here our slope is the reciprocal 4/3, but it's not the opposite sign. So the product of these slopes would be a +1, not a -1. So for this one, the lines are parallel, that's B. And for line or example C here, that would be neither. They're not parallel and they're not perpendicular. The slopes don't fit any of the definitions for these others. Okay, well, that'll wrap up this section. Hopefully, again, useful and lots of information, and you'll have your practice and certify.